We are super happy that you spend this time with us. Thank you very much. So Noam is from Oxford University, and he's going to talk about, I think, a very important and quite unexplored topic, which is how to improve interventions and prepare scaling remaining in the framework of experiments. And we all know that scaling is really the topic that attracts a lot of discussion nowadays. It's a very open question for everyone. So it's a very timely project, and I hope it will be of a lot of interest to people who follow the IDEE program, because the IDEE program is very much about running experiments, but also working with national education to see how we can use the experiments to change policy. So this is going to be extremely exciting. So the floor is yours. We have 1 hour. People may ask questions as you talk, or maybe make final comments at the end if we can keep like 10 or 5 minutes. So the floor is yours. Thank you very much.
Wonderful. Well, thank you so much for having me. Really looking forward to the discussion. So yes, please feel free to jump in anytime, and I'll also leave a bunch of room for discussion. So great to join you. Also very excited about the topic of scaling. And I should say I'm also the academic director of a center called the What Works Hub for Global Education, where the whole focus is on scaling science and implementation at scale. So it's a topic I'm really excited about. Today, I'll be presenting a paper called Optimizing Tech Tutoring Programs for Scale, and evidence from 10 randomized A/B tests. And I'm going to talk about the power of both randomized trials, but also a slightly faster, nimbler version of that, which is referred to as A/B testing. Great. So yes, we'll start with scaling effective education approaches, then the role of A/B testing, then I'll present some results from 10 rapid A/B tests, and then I'll conclude. So just some context in terms of the educational context, the thematic
sorry, no,
context.
Sorry, no, I may
Yes.
be the only one,
Yeah.
but I no longer see your screen.
Oh,
Is that just me?
I see.
No,
Okay.
I
Okay.
can see it.
Yeah, we can
Same.
see
I
it.
can see
You
the
can
slide.
see
You
it.
can
Okay,
see.
so move on.
Okay.
Maybe there's just something I have to change.
Okay. And have the slides progressed for people? Is that you're seeing the learning crisis slide for those who can see it?
Yes,
Yes.
we do.
Yes.
Yes. Okay. Wonderful. So the learning crisis, there's this phenomenon that's increasingly been documented where children are in school in many developing countries, which is wonderful, but unfortunately they're not learning very much. So there's some data suggesting from the World Bank that over 70% of 10-year-olds in low and middle income countries still can't read a simple sentence. So they're in school, but they're not learning how to read. There's high demand for governments for cost-effective education programs that can address this challenge, as one could imagine. And some good news, there's a growing evidence base on things that do work. There's a recent effort called the Global Education Evidence Advisory Panel, which tries to curate the best evidence available and put forward some recommendations on what's cost effective, abbreviated as the GEEP. And so that's good. So we have a sense of things that can work. It's not that we don't know what can work, but the challenge is when these things go to scale, often the effectiveness really decreases or sometimes vanishes. And so what can we do about that? And I saw that a comment came in the chat. I don't know if I should try to look at those real time. Okay, let me see if I can see.
Mark, I don't know if you were talking, but
I see. Okay. Okay, great. So let me keep going here. Oh, is it clicking? Yes. Okay. So A/B testing. So we've kind of reviewed that there's a learning crisis. We do know some things that work, but at scale, it's very hard. So part of the power and potential of A/B testing is it's all about iterative, ongoing testing. And it's regular, it's kind of happening over and over again. So this might be a way of trying things, trying them again, tweaking, revising, and trying to reverse the pilot to scale voltage drop by increasing cost effectiveness and scalability over time. This is related to some work on kind of the science of innovation and the power of innovation, as well as approaches like adaptive sampling, adaptive testing, which are also about this kind of adaptive iterative process. A/B testing is a very common approach in the tech sector. Right, so Google, Amazon, Microsoft, they're all running randomized A/B tests on us every time we're using their platforms. They're running an experiment on us, and to see which version of the platform or which features of the platform work better, these are randomized tests. And they improve productivity quite a bit. They improve revenue quite a bit. So it's really taken off in the tech sector. But still in the social sector, it remains rare for governments or NGOs to have the in-house capability to do ongoing rapid testing. A lot of the rigor that we've seen is being done kind of from outside research organizations, right? By faculty, academics, JPAL, but it's not an inbuilt part of government yet or of nonprofit work, but it has become in the tech sector. So what is A/B testing? How is it similar and different to RCTs? Similar to RCTs, it's rigorous. It's randomizing different groups. And so you can have causal inference, which is great. So that's a commonality with RCTs. Now, one slight difference is in a typical A/B test, you don't necessarily have a pure control group. And so the question is slightly different. You actually have two treatments often. And so whereas in a typical RCT, the question is, does it work? In the typical A/B test, the question is subtly but importantly different, which is how can it work better, cheaper, more scalably? So you're doing version A versus version B. But it's randomized, you're getting rigor, you're getting causality. Another distinction is it's often a bit more rapid. So you're using indicators that happen a bit more quickly. You're not waiting a year or 2 years for kind of downstream outcomes. You're using things that are happening more quickly. And then you're iterating more quickly with those indicators to inform real-time decisions. And it's regular. It's built into kind of the in-house fiber of the implementing agency through existing M&E systems. And it's regular in the sense that you're doing multiple tests in rapid succession, with each one building on the last one for a kind of learning agenda over time. So it's not a single slice, it's multiple slices, and they should be building on each other. So now applying this to an educational context. So tutoring is one of the most effective educational approaches in the literature, but it remains very hard to scale due to high cost and complex logistics. Some effective tutoring programs in high-income countries are estimated to cost over $2,000 per child. So that's going to be very hard to scale. So first, we're leveraging technology to improve cost effectiveness in the first place. So we're using phones and different types of technology to just make the whole thing cheaper. And then we're also doing this rapid, rigorous A/B testing approach to keep finding ever more cost-effective enhancements. So what's the program that we're looking at? It's a tech tutoring program, and it has two key features. It has a platform which is high access, mobile phones. So while households in low and middle income countries don't always have access to the internet, over 80 to 90% of households have access to a mobile phone, a simple mobile phone. So that's a way of really reaching people at scale and cheaply. And it also has a critical component on pedagogy. So you're reaching people and then you're delivering a proven pedagogy. And this is focused on targeting the instruction. So this is something that's been tested time and again. So this is ensuring that a child who doesn't know addition is taught addition. A child who doesn't know subtraction is taught subtraction. It's tailored to each child. It's not a one-size-fits-all curriculum. Another version of this model in school has been called teaching at the right level. There's been a lot of evidence on that. And this is a version of that delivered through the phone. There's also computer-based versions of this. So that's the idea. You're really targeting the instruction. And it's in simple numeracy, basic skills in numeracy: addition, subtraction, multiplication, division. There's a really frequent and cheap assessment that's done quickly over the phone to assess the level of the child. And then that's used to teach the child at their level. So again, these key proficiencies: addition, subtraction, multiplication, division. There's also place value proficiency, so highly targeted. Now,
No,
this is a, yes, yeah.
So those exercises that get on the phone, it's in a different time from the tutoring itself, or they're just during a tutoring session, moving from talking to the person to answering questions on their phone? How does that work?
Yes. Yeah. No, so it's a great point. So it's part of the session. So it's either in the early part or the latter part.
Right.
Sometimes actually both. It's a little bit, we leave that at sometimes the discretion of the tutor. And so they're actually calling the same households every week usually. And so they can either do it at the end of the session and then they know where the child left and they can pick up the next time, or they can do it at the beginning of the session and then use that to tailor the instruction real time. They tend to prefer to do it at the end of the last session, so that way they can prepare for the next session, knowing the level to teach coming into the next session.
Okay. Thanks.
Yeah, but it's not a separate kind of layered in intervention. It's part of the intervention.
Thanks.
Yes. Now, this is an approach that already has substantial randomized trial evidence behind it. So we have a randomized trial that we conducted in Botswana, actually starting during the COVID pandemic. It was the world's first evidence on distance education during the pandemic, and that's on the right. We published that in Nature Human Behavior, and then that got a lot of attention. And then we replicated that in 5 additional RCTs around the world. You can never have enough RCTs. So we did an additional RCT in India, Kenya, Nepal, Uganda, and the Philippines. And in all of those settings, it actually worked pretty well. So there's a lot that we learned about scaling just from that. So I'm happy to kind of get into that. That's kind of a whole related but slightly separate talk. But this is an approach that has a lot of evidence, and it has evidence across settings. It's quite robust. So we feel pretty good this is something that can work. So now coming to, okay, so this is something we feel can really work, internally valid, externally valid. Now we really want to optimize cost effectiveness and scalability. So we're going to try lots of little tweaks to the program back in Botswana, where it was initially tested, to continually improve the cost effectiveness. So we're looking at a bunch of different things. So these are a few examples. So one example is looking at the dosage distribution. So the typical call is happening once a week per household for 20 minutes. It's actually very short. And then a tutor or teacher maybe has 15 to 20 households that they're working with. And so they're kind of, but it's one-on-one, right? This is tutoring. So you're kind of cycling through the children. So you're calling for 20 minutes, and that's the amount of instruction that you're providing. But one of the challenges that often teachers will say is it's just really hard to schedule the household and get a hold of the household. That's actually the hardest part. They often spend an hour just trying to schedule the household. They'll call, the household says, call back later, or something will be going on in the household. And there's a lot of waste in that process. So one of the things that the teachers actually said is, once we get a hold of the household, can we keep them on the phone for longer? Can we do 40 minutes instead of 20 minutes? And then instead of calling them every week, can we call them every other week? And that way, it's actually the same dosage, but it's distributed in a more efficient way because there's less time wasted scheduling or calling into the household with no instruction. So that was a sequence of tests that we ran. Another sequence of tests that we ran were around motivational nudges, so kind of testimonials from other households, other parents about the program to see if that worked. Another set of things that we tried were adding a bit more kind of add-ons to the tech package. So we tried WhatsApp videos as well as the phone call. We tried SMS messages. And then a final area that we really targeted is caregiver engagement. So this phone call is happening with primary school children, but they often are kind of being mediated partially through their parent or caregiver. So you're calling into the household, often it's the caregiver's phone, and they're sometimes putting the phone on speaker and staying around for the session. Sometimes they're leaving and leaving the child on their own with the teacher or tutor. Sometimes they're actually co-instructing. So kind of versions of this are unstructured and we leave it up to the caregiver. So that was kind of version A. In version B, we tried to give it more structure, and we actually asked the caregiver to take over the call halfway through. So it was an explicit ask for them to co-instruct, and I'll share the results of that. So we're trying different modifications on the base program to enhance cost effectiveness. So this is taking place in Botswana, 10 A/B tests. These are all randomized over 14 months. Total sample size of a little over 11,000 children. Average age is 9, half the sample is female. Average grade is grade 4, though the children are grade 3 through 5 in total. We're finding great balance across the arms, fairly high response rate as well. No attrition, 71% response rate. And this is a map of households who are participating. There's 2 types of tests that we're looking at. So one is a bit more traditional. That's effectiveness increasing innovation. So these are often things where you're improving or you're adding program components. And I think that's a very familiar kind of test to all of us. There's a second category, which I don't think we test as often, but is really important, where we actually are looking here at things that reduce cost, but don't necessarily improve impact. So these tests are interesting because success actually would be no difference in impact in this case. So if it's cheaper and just as good, that's an improvement. Now that presents some different challenges in terms of power. Detecting a zero effect is a little bit trickier. There's sort of a couple things that go into this, but it's a class of innovations that are really important for scaling programs that we're not always testing. And in this case, we're looking at those very seriously. What's the learning assessment? The learning assessment is very similar to the assessment that's used to target instruction. This one is done separately, though. It's not part of the session. It's done in a way that's separate. It's validated. It has some protocols around it. It's timed. You're randomizing different proficiencies. There's actually a series of back checks. So now this is kind of the assessment to actually make sure we've captured learning. We've also validated this with in-person assessment, and it's a tool that's been used in the literature a few times. Learning here is scored on the foundational skills from 0 to 4. So whether you don't get anything correct or you can get up to division, so a place value addition, subtraction, multiplication, division. And you can express this in terms of average level. You can also do standard deviations. It's a little bit tricky given there's not that much variation here, but you can do that. Or you can do the percent correct for each proficiency, how many kids can add. So you can kind of analyze this in a few ways. So here is the result of a bunch of the cost-reducing modifications. So in the first panel, we're looking at tests that looked at dosage distribution. So this is the test that I was mentioning where we're comparing a 20-minute weekly phone call to a bi-weekly 40-minute call. And these are cost-reducing innovations. So each row is a round of testing for this. And here, success looks like no difference, actually. So if it's just as good but cheaper, we're happy with it. And what you can essentially see is there's a slight reduction, negative 0.04, but it's very small and it's not statistically significant. The confidence interval overlaps the 0. And so it looks like it's cheaper, but just as good. Now, just to be sure, because detecting a 0 effect can be tricky, though the confidence interval looks pretty tight, it's not noisy, but we wanted to be sure. So we actually repeated this test just to be sure that it wasn't underpowered, and we find an almost identical effect in the second round, that second row. And when you pull these, it's very powered. So this is for the dosage distribution. We found something that's cheaper and just as good. There was another category of cheaper tests. I didn't mention this in the earlier example, but that we also ran, where we compared the effect of the same tutor calling every week. So there's familiarity, there's comfort, they know the children, or just whatever tutor is available calling. And now that has a trade-off in that they might not know the children as well, but on the other hand, they're available. So again, you can reduce frictions in scheduling because you're getting the next available person. So that saves time, that saves cost. Now that might work better for scheduling, but it might not work better for impact because they don't know the children as well. They don't have the relationship. But one of the advantages they have is we do have information on the child's level. So the new tutor still knows, I need to teach this kid subtraction. So they have that information available in a system that we provide them. So question is, same tutor versus different tutor. If you can make the different tutor work, it's cheaper. And if it's as good, we're happy with that. And again, what we're seeing here is it's slightly less effective, but not statistically significant in the first round. And then in the second round, similar story. Not statistically significantly different. So we repeated the same test just to be sure for the cost effectiveness reductions, and we're seeing that it's just as good. So these are reducing costs, saving time, and just as effective. So this is the class of innovations that were interestingly very efficiency enhancing across the board. So these are the tables that correspond to those figures. You can also see here the pooled results in the far right, and you can see these p-values are not marginal, 0.34, 0.39, or 0.4. The effects are very small, negative 0.03, negative 0.05. So these are pretty precise nulls. They're not noisy nulls. So these interventions, again, are just as good, but cheaper. Now coming to the class of interventions we're a bit more familiar with, the effectiveness enhancing tests to improve learning. And this here, we don't want to see a 0. Now here, we actually want to see an improvement, an increase over the 0 line. So panel A is looking at tech package add-ons. So what was the value add of, in addition to the phone call, having an SMS message? We actually find that here we actually don't repeat the tests as often. Sometimes we repeat them, sometimes we don't because they're more powered. And so for the SMS, we see a slight positive effect. It's on the margin of statistical significance, 0.1 standard deviations, but very cheap. So that's kind of promising, not conclusive, but promising and very cheap. The additional WhatsApp videos, not a big effect, 0.02 standard deviations, and not statistically significantly different. So we're not seeing that adding the WhatsApp videos, adding extra content is adding very much through that. I think it's often just a medium that's a bit passive. It's hard for people to engage with. Motivational nudges in the second panel, we tried different versions of this. That didn't seem to work very well. And then this final panel was quite striking. So this is the test where we're asking the parent or caregiver to take over halfway through. And about half agree. These are intention to treat effects. They're not treatment on the treated effects. Half agree. And the intention to treat on that is 0.24 standard deviations, which is just dramatic. And the marginal cost of this is very, very low. So the parent's taking over halfway through, even if you consider opportunity cost, it's 20 minutes, very, very cheap, very, very effective. Then we repeated that. We were so surprised this was so effective. We repeated it. And again, it was similarly effective. So then we felt very confident about this.
Noam, can you say again what's the difference between encouragement and expectation versus choice? I forgot.
Yes. Yeah. No, so this is subtle. So we, in one version, we say, can you take over?
Yeah.
And in another version, we say, take over. So it's actually very, very subtle.
Okay.
We were trying to see if that made a huge difference. It looks like that subtlety doesn't make a huge difference, but the kind of them taking over is what's making a big difference. We wanted to see if adding a little bit extra flavor of choice made a bit more difference, essentially, with the subtle wording phrase. But it's essentially a repeat test is how I would think about it. Yeah.
Okay.
So about half to 60% of the parents are taking over as a result halfway through the call, and that's what's generating these effects.
Every time the control group is the standard version. Is that right?
Yeah, so it's a great point. So it varies a little bit, which is one of the tricky things with these tests. So in some cases, it is the original. So for some of the tests, depending on the sequence of when they happened, the control group was the kind of original, but then over time, the program's evolving. And so then it becomes the latest version of the program.
Is that why baseline mean? Baseline mean is control mean? Is that what it means?
Yes, exactly.
So
exactly.
They vary a lot, yes. That's the reason?
Yeah, they do vary. I would say they don't vary too much. They sort of these are not standard deviations, they're sort of average levels. So like the difference between 1.92 and 2.24 is the child almost knowing subtraction and knowing a little bit more than subtraction. So it's actually not a huge difference in kind of practical terms. They vary a little bit, but not a huge amount.
Yeah, but they vary more than the variance, than the effect of the variance. That's why
Yes, no,
yeah.
Yeah, so the baseline mean is not in terms of standard deviations, whereas the effect sizes are in terms of standard deviations.
Okay.
But it's true that there's some variation. It's true that there's some variation in the control mean. So part of that might be exactly that kind of the program's adopting and adapting a little bit over time. Yeah.
Yeah, but do we agree that so if you want to compare, okay, no, it depends what comparison you want to make, right? When you compare two dots on this graph. If the baseline has changed, well, the difference between the two versions is not the size, the distance between the two dots. It's also has to be adjusted by the distance between the two control groups, right?
Yeah, no, so that's a great point, actually. And we're still working through some of that, kind of how to think about that. So that's very helpful. And so, yes, that's kind of one of by doing so many tests, how we aggregate them, how we kind of consider the comparison group. That's some of the trickier bits of this. So that's great.
Okay.
Yeah. Okay. Then this is the table equivalent. I kind of talked through that. Now getting to cost effectiveness. So we wanted to calculate cost effectiveness. That's such a big point of all of this. So there's the traditional cost effectiveness calculation, and that's looking at the change in impact over the change in cost. So we look at that. But this proved tricky for the cost reducing innovations, because in the cost reducing innovations, success looked like no change in impact. And so even if the cost is reducing, if you use the traditional cost effectiveness calculation, you're not able to pick up the efficiency gain because it's zero when it's successful, even though the cost has gone lower. So you're not picking up the difference. There's sort of a flooring effect of sorts. So the traditional cost effectiveness calculation wasn't really working to pick up the efficiency gains of cost reducing innovations. So we're introducing something very simple, but that's going to try to be a bit more symmetric on the efficiency gains, which is essentially just looking at the change, whether it's cost or impact, depending on the type of test you're running, relative to the control mean or the baseline. And so here, if you reduce costs, we're just saying what was that reduction relative to the baseline. Similar if you're changing the impact, what was that impact change over the baseline or the control mean? So we're going to calculate
Sorry,
both
I have a question.
Yes. Yeah.
With respect to the cost, like in this intervention that you did 20 by 2 instead of 40 by 1, like how much is the difference in cost? It's just that the wages of the tutor, so because it takes more time to connect. So it's just that, or what else do you include in this reduce?
Exactly. No, exactly. So it saved time, and then we attach the wage to that. Exactly. Yeah.
Thank you.
Yeah. And actually, that turns out to be the biggest cost of most programs is salaries. So actually, that ends up being a big piece of the cost equation. So here, looking at some of this, so we're looking here at the various tests and the cost differences, the impact differences. And then here, this is cost reduction. So we're just looking at that simple efficiency gains metric. And you can see that, you know, the dosage distribution test is roughly just as good, but is giving you 19% efficiency gains on the cost. Because you've reduced cost a bit, you've reduced it by about $6 off of a baseline. The baseline isn't included here, but the baseline is about $25 to $26. And so we're getting a efficiency gain of about a fifth. For the implementer type test, similar cost reductions and time saved and similar efficiency gains. So that is for this. So we're seeing pretty large and consistent efficiency gains from the cost reducing tests.
So am I correct to say when you write those figures, when you say 19, you assume that efficiency gain is 0?
In what sense?
Well, the learning difference, there's a learning difference that is very small. So you consider it is 0, and you only look at the variation in cost between the two things. When you say I have an efficiency gain of 19. Right? You don't scale this by the learning difference, right? You assume learning difference is 0 for the same learning effect. I get a reduction in cost from 5.7, and this is 19%, right? You don't you accept the null that it's a 0 effect.
Exactly.
Okay.
So the way, because we were trying to, I mean, we're actually still thinking through what the best way to capture these efficiency gains are. So if folks have ideas, that's very welcome. We were finding that the cost effectiveness calculation that's usually done didn't work well for the cost reducing tests. It works for the effectiveness enhancing tests. But because you get a 0 when you have a success, you're not able to pick up the reduction in cost in the traditional cost effectiveness calculation. The numerator is 0. So it produced, we weren't able to detect these efficiency gains. So that's why we're using here. It's just, the efficiency gain is just referring to the cost saving. Right. Exactly.
But you would agree that there is some uncertainty of the efficiency gain on the efficiency gain that comes from the standard error on the estimation of the learning difference, right?
Yes, and we're trying to figure out how we account for the impact,
which would be
there's
small
a cost
in
reduction.
That case, because you have a lot of precision. But nevertheless, in principle, there is some uncertainty around the 19 that comes from the uncertainty around the learning gain. Is that correct?
Yes. No, I would agree with that. And there's also uncertainty on the cost, actually, because the cost doesn't have standard errors in this case. We need to introduce some. There is some uncertainty on this on both sides, actually. But yes, this cost and the efficiency gain, we've defined it as efficiency gains in terms of cost savings. So actually, here we're not saying efficiency gains in terms of cost effectiveness on purpose. We're saying efficiency gains in terms of cost savings. But welcome thoughts on this. We're kind of still thinking through how to capture these efficiency gains in the best way possible and in a symmetric way across the cost and the impact side of the equation. For the effectiveness enhancing test, here we can do the traditional cost effectiveness calculation, learning gains per $100, and this is in terms of standard deviation gains per $100. Then we also calculate the efficiency gain, but this time just on the impact side. So what's the efficiency gain from the impact gained relative to the baseline or control impact? What we're seeing here on the efficiency gains, there's some that have no efficiency gains. Remember, some of these effects had no effect. And so there we're getting zeros, but in some cases we're seeing efficiency gains, the SMS 33%, the caregiver takeover 30%. So these are large efficiency gains, actually slightly larger efficiency gains than the cost ones, but less consistent. Some of them work, some of them don't work. Now, something is also missed a little bit in the efficiency gain here because you're not considering both sides of the equation. So when you look at the learning gains per $100, you're seeing fairly dramatic differences in these. So up to 30, 50, 200 standard deviations gained per $100. Now that's kind of a funny number when you're sort of scaling by a very low cost, but it sort of just gives you a sense. It's a kind of simulation, I would think about it, exercise of how cost effective is this. Okay, so significant gains from rapid, rigorous, regular testing. As mentioned, the baseline program was already shown to be effective. In the original study in Botswana, it got you 0.12 standard deviation. So some of these small changes are actually giving you gains that are almost as big or bigger than the original program. So that's really striking. Half of the A/B tests are giving you these big gains. This is very comparable to success rates from the tech sector. So in the tech sector, the literature suggests that 10 to 30% of modifications are more effective than the status quo. Here we're finding it's closer to half. So we've actually found a very high hit rate of this process. Some of these cost effectiveness gains that we mentioned are in the top percentile of education literature in low and middle income countries. So these are really big gains relative to what else has been shown to be cost effective in the literature. Now, another thing that we looked at is priors and posteriors by the teachers and tutors themselves. So did they predict these results? Did they kind of have a sense of what the results were? And how were they influenced by the actual A/B test? So what you can see here in the blue, this is pre-intervention. This is the distribution of beliefs about the difference in impact between the modification and the status quo. And this is looking at a test where the true difference ended up being 0. So those cost reductions, we found essentially no effect with some uncertainty, but no effect essentially. And what you can see is most people predict that when you take something away or you sort of, reduce the cost, things are going to work less well. So that's the prediction in the light blue. The distribution suggests that people think it's going to work less well when you simplify it. But in fact, in the red, we see that there isn't much of a difference. And then post-intervention in the black line, you can see that teachers update their beliefs. So they're quite responsive to the result of the test. Actually, they don't fully guess it, and then they actually get it once they do it. So this is suggesting that kind of expert predictions, which are always very valuable, but there's something to learn here. You can't just predict these things kind of from intuition or experience always. And also that they're malleable, that people are actually quite responsive to the results, which isn't always the case. So that's promising as a kind of process to inform decision-making. So some concluding thoughts on this, and then I have one final slide after this. So over the course of 10 successive randomized A/B tests, we evaluate multiple versions of a tutoring program, which was hard to scale, or which is effective, but these types of programs can be hard to scale. But we find ways of making this much more efficient and cost effective. Now, the cost reduction innovations are producing quite consistent efficiency gains, but the effectiveness enhancing ones less consistent, but a bit more efficient when you get it right. And overall, these results are just suggesting that this type of iterative testing can be really valuable, that if you're not doing this, you're leaving impact on the table, essentially. And this is really helpful for unlocking the scaling challenge. So we're really excited about this approach going forward. One final slide just to say, it's something that I've been working on both through the What Works Hub for Global Education. This is now a big focus of the center that I mentioned, and also through Youth Impact, which is how we did the tests that I just shared in this paper. So Youth Impact is an NGO that we co-founded over 10 years ago, initially to scale up RCT-backed health and education programs. In the process, we realized as we were scaling that there was a lot more to learn. And so we actually developed this A/B testing process. And so in 2014, you can see in the figure here, we did our first RCT. Then we did that was what we had done. Then we built more in-house M&E systems. We started rapid iterative testing in 2017. And then by 2024, last year, we had run 53 of these randomized tests across various programs. So you can see the kind of dots are when we do an RCT, when we do an A/B test, and then there's the cumulative number there. So Youth Impact both scales RCTs, runs RCTs, and now also runs lots of A/B tests. So it's a process we've gotten very excited about. Youth Impact is headquartered in Botswana, but has offices around the world: South Africa, Namibia, Philippines, partnerships in Uganda, Kenya, India, and more. So those are two places where we're really putting a lot of energy into this approach, but others are also doing this approach as well, and it's starting to take off. So there I'll end, and looking forward to the discussion.
Thank you very much, Noam. Just before I give the floor, so just a clarifying question. So at the end of the day, so your baseline estimation of the intervention is 0.12 standard deviation, right? That was your basic figure. So if you were to improve it by the most efficient version at similar cost, let's put it this way, you would move from 0.12 to how much? I'm not sure you gave that summary
No,
figure.
you're right.
Yeah.
I didn't give that, actually. One of the reasons I didn't is it's a different sample. The original test was a different sample than the kind of final A/B testing sample. But that would be a useful exercise. So I actually haven't calculated that, but we should calculate that, because you're right. That's, in a way, that's the bottom line, actually.
Yeah, at the end of the day, you want if you move from 0.12 to 0.13, or if you move from 0.12 to 0.25, it's not the same story.
Yes.
But I guess that this 0.12 was when there was the pandemic, right? Or
so right. Yeah. So it was a different setting, different sample. So it's not clear exactly how to add all of these results. But I will say, I mean, one thing we could do, we could reintroduce a control group now with the current version of the program to estimate the kind of effect of the total package. So that's something that we could do. So there's sort of now the fully loaded program with all the modifications, and it doesn't have a control group. It's A versus B each time, but we could reintroduce the control group and then C. So that would be one way of doing that. We haven't done that yet, but that could be an option. So that's a great suggestion. Or we actually have just monitoring data, and we could do kind of a difference in difference. We don't have to randomize, but we could do some kind of difference in difference with that to get kind of a quasi-experimental estimate of the total effect. Yeah, or we could try to add them in some sensible way. We have to think about how to do that.
Other questions? So I had two more questions. So I think you mentioned the KZ, and I forgot the other author's name at the beginning. So they have a rather...
This is the adaptive testing.
Exactly. They have a rather complicated paper.
Yes.
But basically the idea is you can save on sample by dropping, as soon as you get enough information, you drop that experiment and you use whatever sample you have available for the next experiment, something around those lines. I read that a long time ago. So that's obviously not something you did. Actually, I haven't seen applications of that, but maybe, I don't know, in computers, in text, they're doing that. I don't know, but I haven't seen that much. So maybe it's super complicated in practice. Or didn't you do it just because you don't have issues with sample size? You have huge samples where you can go ahead with A/B testing all over the place, and it's a marginal issue for you.
Yeah. No, so it's a great point. And we've looked at that approach, and there's a lot in that approach that we're really excited about. I think there's two things. So one is it's very elegant mathematically, but in practice, it's quite hard to do. It's very automated, right? The whole idea is it's kind of automatically switching between treatments based on information. So it's actually hard to make. You need really good data systems. You need good software. It's actually hard to make happen in practice. So I think at some point it could be, but at the moment it's a bit hard to do in practice at large scale on a program that's not fully techified. So as you're alluding to, and a thing that's a bit more fully tech in the tech system, it could be more possible. But school things in households, right? It's not an app. It's kind of it's not a smartphone, right? It's a bit harder to get that kind of automation in that setup.
Right. Right.
The other thing is we've taken a very decision-making focused approach to this work so far, where our lens is how do we embed rigorous rapid evidence into a real-world decision-making process. And the thing actually that we're finding in the in that setting, right, is decision makers, as we can imagine, are comfortable with more uncertainty. They actually don't need lots of certainty.
Okay.
And one of the benefits of the adaptive sampling is it gets you more certainty. And because essentially what's happening is in the short run, you're reallocating treatments. And then in the long run, the treatment gets more sample that's most powered. And that gives you a bit of a precision benefit is kind of the gist. We find that that's not what decision makers are asking for in our setting. They're actually, they don't need a p-value of 0.001. They're sort of happy actually with even 0.3, to be honest. They don't need even the 0.1 threshold that we use in academia. So from a decision-making point of view for kind of policymaker and practitioner, we've actually been leaning toward how we do things with more uncertainty rather than do things that get us more certainty.
Okay.
Yes, but there's a lot of, the notion of adaptation and using prior results to inform the next results, that's all very similar. And, the spirit of that, is something that we've drawn a lot of inspiration from.
Right. Okay. And my other question was, so you didn't test joint versions of the different variants. So is that because it would be too many, or did you have any reasons to believe that there are no complementarities between those different versions? And there would be no significant additional gain from them, from joining them. Yeah.
So we could. There is a lot of information in these 10 tests. Aggregating them and analyzing them jointly is just complicated because the variations are not neat.
So
but
sorry, maybe that's not what I meant. I meant testing joint version, testing versions where you simultaneously have several variants.
I see, together. So you're not changing one thing at a time.
They're not necessarily exclusive, right? You could do, I'm not sure I remember every of them to give you an example, but there are probably interventions that could happen simultaneously.
Yeah.
And if there were complementarities between the two, then maybe the gain would be even higher, etc. And that's not something that you tested, and I was wondering if it's because you have no reason to believe that there would be complementarities, or
that's a great point. We have done it kind of tweak by tweak rather than, tweak one plus tweak one plus two. We could do that, and there could be complementarities. Absolutely. So yeah, it's something we could look at. We've tried to embrace the sequential learning kind of philosophy for this rather than the kind of parallel learning with multiple treatments. We've tried to simplify it so it's not too many treatments at once. But we could do that. We could do a version. We could do a version with 1, 2, and then see what the complementarity is and see if it's not just additive, maybe there's sort of a multiplicative factor. So we haven't done as much of that, but that's something that we could do.
Marcela Vinieri, maybe you want to raise your question directly?
Yes, hi. No, I'm sorry. I joined very late because I just saw the ad of your webinar on X Twitter. So I wonder whether you've got any working paper that you can share on this presentation. Reason being is I am the senior economist at Save the Children UK in their evidence and learning team, and under the education theme, we are doing a ton of these tests on catch-up clubs and teacher catch-up training specific to countries also in emergency states like Afghanistan. So, and we are in the business of doing a ton of cost effectiveness analysis. So I would be really interested in seeing the details of how this has been set up for Botswana and the other countries you're working on, and possibly we can have some exchanges on methodologies.
Yeah, that would be great. Would be very happy to follow up. That's great to hear. And I know the Catch Up Club work actually by Save the Children well. So it would be great to follow up on that. That's wonderful. We don't actually have a public working paper just yet on this, but we do have a presentation. So we presented this at the AAs, at the What Works Hub conference. So happy to share the presentation, but we will be releasing a working paper soon with all of this.
Cool. And we're both based in Oxford, so we can also go for coffee.
Great. Okay, that's great.
Good. Thank you, Marcella. Any more questions? No? Okay. So thank you very much, Noam, for this super interesting paper. And thank you for taking the time to share this with us. And that's it. Good evening, everyone. And see you around, Noam.
Yes, great. Thank you so much. Thanks for the great comments and feedback. Looking forward to staying in touch on this.
Thank you.
Thank you, everyone.
Bye. See you. Bye. See you guys.
Thanks a lot, Noam.